Section 8.6 is factoring ax squared plus bx plus c. I can factor trinomials of the form ax plus bx plus c. So the difference here between section 8.5 is that we have that number in front of our x squared. Here I have an a value. And we have to get rid of that in order to factor the same way. So we're going to use what's called the swing method here. There are a lot of different methods you can use. That's just going to be the one that I use here today. Big ideas for this section. Some trinomials of the form ax squared plus bx plus c can be factored to equivalent forms, which are the product of two binomials. And sometimes the greatest common monomial factor, or the polynomial, should be factored out before the remaining polynomial is factored. In example 1, we're going to factor when AC is positive. So here, the factored form of 5x squared plus 11x plus 2. If we look, our first step is to always factor out anything that's common. I can't take a 5 out of a 2 or an 11, and there's no variable terms to take out. So we can't take out a greatest common factor. Here we could kind of guess and check things that multiply to 5, multiply to 2, and go from there. But we're going to use the swing method. And in order to do the swing method, I'm going to swing my a to the back and multiply it. So I'm going to take a times c and rewrite it. So I'm going to have x squared plus 11x plus 5 times 2 is 10. Again, it's called the swing method because we swung that 5 to the front. Now I'm going to factor this just like we did last section. So to multiply to x squared is x and x. I'm going to multiply to 10 and add to 11. My options here for 10 are 1 and 10, which also adds to 11. I could have tried 2 and 5, but that wouldn't have worked. So here, since I have a sum to 10, I added to, multiplied to a positive 10 and added to 11. My signs are going to be the same. Since my 11 is positive, they're both going to be positive. And I have 1 and 10. Now, this is the swing method, and we can't change an expression like that without, again, undoing it. So, because I multiplied by 5, now I'm going to have to divide everything by 5, my number parts anyway, my 10, to get back to where we started. And we have to divide both of our values here, both of our lasts. We're going to reduce our fractions if we can. 10 divided by 5, for example, is 2. And if it doesn't reduce, we take our denominator and swing it in front of our exponent in just that factor. So here I have 5x plus 1 times x plus 2. So again, we call this our swing method. And we're going to swing a couple different times here. So I swing my 5 to the back as multiplication. I have to undo that by dividing. And then anything that I still have in the denominator, I swing to the front. We can check this by foiling again. 5x squared plus 10x plus x plus 2 gives me 5x squared plus 11x plus 2 when I combine my like terms, which matches what we had here. So this is our factored form. In example 2, we're going to try factoring here again. We can't take a 3 out of everything, and we can't take any variables out. So we don't have a common factor to factor out first. So we're going to head and just use the swing method. I'm going to multiply my a value to the back and rewrite it as multiplication. X squared plus 4x minus 45. Again, I take my leading coefficient, my a value, swing it to the back as multiplication times my c, and rewrite it. Now we're going to multiply to 45 and subtract to 4. My options here, 1 and 45, that doesn't work. 2 doesn't go into 45. 3 and 15 does not subtract to 11. 4 doesn't work. 5 and 9, and that does subtract to 11. So when I set up my framework here, to multiply to x squared, I take x and x. And since I subtracted, I found the difference, my signs will be different. Then I look at my middle sign, which here is a plus, which means my bigger number is positive, my smaller number is the negative. Again, the sign of our bigger number always matches the middle. And our last sign tells us if our signs are going to be different if we find the difference, or the same if we have a sum. Now here, don't forget we have to undo our swing. Since we multiplied by 3, we have to divide by 3. Reduce your fractions if you can. 5 over 3 doesn't simplify, but 9 divided by 3 does. And then our last step is to swing to the front any denominators. 3x minus 5 and x plus 3. Now with these, it's really important that we double check by multiplying back, because if we didn't reduce our fraction here, or if we had the wrong values or forgot to swing here, we're not going to get back to our original, and we have to get back to the original equation they gave us here. So firsts, outsides, insides, and lasts combine our like terms, 3x squared plus 4x minus 15. It checks with where we started, which means we are correct. Now, feel free to pause here and give this a try if you'd like. Again, we look for common factors. 13 is prime, and I don't have any variables there, so there's nothing I can take out. So to factor this, I'm going to use the swing method. Again, there's a lot of different ways. If you like search factoring, quadratics, there's like using a box method, there's splitting the middle term, there's kind of a guess and check type thing, there's one where you just factor, but the swing method has been the one that most people have liked in years past, and so that's the one that we usually use, just to keep everybody on the same page. So here, x squared plus 13x plus, when I took that 6 and brought it to the back, I multiply the last number by 6 and get rid of it in the front. So I have 30 there. So here we are going to multiply to 30 and add to 13. Set up our framework here. To multiply to x squared is x times x. Our options here, 1 and 30, but that doesn't add to 13. 2 and 15 doesn't add to 13. It subtracts there, but keep in mind we're adding to 13. 3 times 10 is what we're looking for. Since we found the sum, our signs are going to be same and they're going to match the middle here. 3 and 10. But we're not done. When we multiplied by 6, now we have to undo that and divide by 6. Again, reduce our fractions if we can. 3 over 6, I can take a 3 out of both of those and have 1 over 2. And 10 over 6, I can take a 2 out of both of those and have 5 over 3. Final step here, we take our denominators and swing them in front of our variables. It's like undoing our swing. So we swung, and now we're undoing our swing. We multiplied, and we had to undo it with division. So here I'm going to have 2x plus 1 times 3x plus 5. Again, let's check it. Firsts, outsides, insides, and last, when we combine our like terms, 6x squared plus 13x plus 5, which checks with what we started with, so our answer is correct. Now, feel free to pause here again and give this a try if you'd like. If we look again, 31 is prime. I can't take it out of a 10 or 14, and I don't have any variables to take out, so I don't have a greatest common factor to worry about. So I'm going to use my swing method. I'm going to multiply 10 in the back, so swing from front to back as multiplication, and rewrite it. X squared plus 31x minus 140. I need to multiply to 140 and subtract to 31. My options here, 1 and 140, that doesn't work. If we take 140 and divide it by 2, we get 70. That doesn't work. It doesn't divide by 3. If I take it and divide by 4, I get 35. And when I subtract there, I do get to 31. So these are going to be the values that I'm looking for. As far as setting up my framework here, to multiply to x squared is x times x. I need to multiply to a negative number. Remember, we subtracted, which means we found the difference, so our signs are going to be different. And since our middle number is positive, our bigger number is going to be positive. 35. Smaller number, 4. Now, we're not done here. We need to undo our first step. We need to undo our multiplication by dividing, reduce our fractions, and then we need to undo our swing from front to back by swinging then from back to front. So we swing our denominators, 5x minus 2 and 2x plus 7. Now, let's check here. Firsts, outsides, insides, and lasts. Combine our like terms. And what we got when we FOILed matches, so we know our answer is correct. In example 3, we're going to be applying trinomial factoring. The area of a rectangle is 2x squared minus 13 minus 7. What are the possible dimensions of the rectangle? So again, we have a rectangle here, and we have length times width. So we need to get this down into two things that are multiplied together, two factors. In order to find the area, we take length times width. So here is in standard form our answer, but we want to know which two things to be multiplied together. So we need to factor this. 2x squared minus 13x minus 7. I'm going to start off by using my swing method. X squared minus 13x minus 14. Remember, we bring the 2 to the back as multiplication. Now I'm going to multiply to 14 and subtract to 13. My options are 1 and 14. I also could have done 2 and 7, but 1 and 14 works. So when I set up my framework here, to multiply to x squared is x and x. Since I found the difference here, I need different signs. And the sign in the middle tells me my bigger number is going to be negative. Now we have to undo our first step there. We have to undo our multiplication by dividing. Remember to reduce our fractions if we can. 14 divided by 2 is 7, but 1 over 2 doesn't simplify. So we've undone our multiplication. Now we need to undo our swing and swing that 2 in front of our x. So my possible dimensions then are x minus 7 and 2x plus 1. Let's multiply those back and double check. Firsts, outsides, insides, and lasts. When I combine my like terms here, I get 2x squared minus 13x minus 7, which checks with our original. So here our dimensions are 2x plus 1 and x minus 7. So based off how I drew my triangle, this would have been x minus 7. This would have been 2x plus 1. Because this is a longer side, if we double it and then add to it, it's going to be bigger than if we take a number and subtract. Again, that part's not as important, but finding the two dimensions are. And all we're looking for there are our factors. I'm going to stop this one here and finish this section in another video.